Assalamu alaikum students. In this short video, we are going to study how to estimate the ARCH and GARCH models using EV. These are the most important steps which Dr. Marashi has taught you very well. First, we have to go for a mean equation. It can be ARMA, RB, or ARIMA model. Then, by that mean equation, we will use the residuals of any of these equations to see whether there is an arch effect or not. If there is, then we will go for arch effects, and then at the end we will go for diagnostic. As far as forecasting is concerned, for forecasting, you can see the video on forecasting which we have studied earlier. It was some video in lecture number 30. So I'm going to straightforward go to the data of S&P 500 index. This is not the the prices for the stocks, but this is the in fact the index, the market index of the New York Stock Exchange. It is known as S&P 5000. So let's open the original data, and we have seen the graph of this data before as well. It is non-stationary. It is non-stationary. We know normally it is random walk, so non-stationary. And if we look at the histograms, of course, so ACF is decreasing very slowly. Partial PACF is decreasing exponentially. So this is the sign of non-stationary series plus autocorrelated series. And also, if you go for the unit root test, which is called, there are different types of unit root test. We have studied the Phillips and the Kowalski, but we'll go for augmented neighborhood test. Okay, and the p-value is greater than 0.05. So we are not going to reject this null hypothesis. And the null hypothesis is telling us that the series is non-stationary. Okay, so we will do one thing more now by opening this thing. Let's go for what do you call it? Another thing was, let's open the series and let's go for auto forecasting, because before we go for ARCH model, we have to fit the mean model. Step number one here. Okay, so options, tick all the available options. Okay, and let's see what we have. We have to wait for a while. So it is giving us, we must have different series. Yani, we must have stationary series, and the model is 4 ARMA, sorry, AR4 and MA4. And if you see here, AR4 up to AR4, it is significant. For command has a significant, and there are some other models as well. There are some other models as well. It says 2 is also good, 4 is also good. Very less difference here. Very less difference here. Very less difference here. So let us go. Let us go for 4 4 So the first thing is, let us go for returns. So I have already done the returns. You all know how to do the returns. This is the series of the return. And now we fit the model. So model was what? Log of returns of price. See AR1, AR2, AR3, AR4, MA1, MA2, MA3, and MA4. options the same. We need maximum likelihood method for estimating the parameters. Rest everything is the same. Let's see the parameters. So all the parameters, the first one is constant. It is not significant. The rest, all of these are significant. All of these are significant. Okay. Then once we have fitted the model, then we do use the residuals of the mean equation to test for arch effect. So we have, this is our mean equation. This is our mean equation. So if we write it in the form of the equation, that will be our equation. Once we have the mean equation, then we go for residual testing. Number one, let's go for correlogram to see whether this model is good or not. Not 36 lakhs, let's go to 20 lakhs. Yes. So model is stationary and there is no autocorrelation. Okay, let's go for squared residuals. Now, this is very, 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 very important, students, in order to apply for ARCH or GARCH model. Just see this thing. Let's go to 20, and it says yes. We need to have AR, not AR1, AR1, 2, 3, 2, 3. So it can be AR, maybe 3 or 4. 1, 2, 3 or 4. I don't know. We will see this thing. Let's go for residual directions. The third thing is heterosidasticity test. This is also called Lagrange's multiplier test. And number of lags is 1. Okay. Significant. This means there is an arch effect. There is an arch effect, right? What was the, let me go back here. And let's see. Mean. Okay. This is, so we have, this is your arch model. This is your equation, right? This is your mean equation. And for this mean, you have estimated the model, that is C plus AR1 plus AR2 plus AR3 plus AR4 plus MA1 plus MA2 plus MA3 plus MA4, and then this error term. So you have all this thing here, right? And this is going to be your arch equation. That is the variance equation where we'll be having alpha naught and alpha I. This is for arch B. For arch 1, it is going to be alpha 1. Alpha 1. So there are some EVs output also here. EVs output. We will study this thing right now. Okay. So we have the arch. P value is what? P value is less than 0.05. So we will check the H naught. And what is the H naught arch? That there is no arch effect, but since that thing is rejected, so we have the arch effect. And this is the statistic that you have to do. This is the statistic that you have to do. Okay. And then we will go for what? We go for estimate. And then we go for testing arch effect. Here, instead of least squares, we'll go to arch. We'll put here 0. We don't want GARCH, we would like to have arch. And in options, always put legacy dialogues, EVC legacy, as proposed by Asterio, because he is the one who has written a very good book on forecasting ARCH and GARCH. Okay, let's see the arch effect. Yes. So the coefficients are all significant and the arch effect is also significant. Yani, the volatility, the variance of today will depend upon the squared residuals of yesterday. But this is one arch effect. Let's go for two arch effect. Let's go for arch 2, same things. Again, the six. Let's go for 3 arch effect. Again, we see there are 3 arch effects and all the parameters are significant. Okay, let's go for the 4 arch effect. Again, the assay. Let's go for 5 arch effects. Again, the R significance. Let's go for 6 arch effects, 6 leg arch effects. Oh, now what? They are significant, but here the coefficients, some of the coefficients are not significant. So the best will be we should have 5 arch effect up to 5. Okay. But students, this was arch. But in arch, how many parameters will be there? You see how many parameters will be there? 1, 2, 3, 4, 5. We are using 5. If we are using 5 in this very situation, there are going to be 5 parameters. And in the mean equation also, there are going to be 5. 8, 1, 2, 3, 4, 5, 6, 7. Too many parameters. So, in order to overcome this thing, we will go for GARCH effects. We'll go for GARCH. So put here arch 1 or command GARCH 1. Command GARCH. Options same. Okay, let's see what do we have in GARCH effect. So now we have this residual, this coefficient is for arch and this is for GARCH. Both are significant and all our estimates are also significant. This was your mean equation, variance equation. You get my point? And this is your GARCH model because this alpha is for arch effect and this beta is your GARCH effect because with alpha you have squared residuals, with beta you have squared variances of the past term. That's why it is called GARCH model, as Dr. Marashi has taught you very well. So C3, this is going to be your alpha, and C4 is going to be your beta, and both of these are significant, right? You should all go through these interpretations, which are very, very important. And if you add alpha plus beta, it should not be greater than 1. It should be less than equal to 1. If it is less than 1, this means what? Indicating high volatility. And if it is near to 1, this means high volatility clustering. Remember this thing. And shows decay slowly but are not permanent. Shocks decay slowly but are not permanent. In the shocks, the volatility is there. It is going to decay but very slowly. So there is a persistence of volatility in the series. Okay. Let's go for something else. Let's go for something. I would like to go for. I would like to go for. I am going to make GARCH. This was GARCH 1-1. I would like to make a GARCH variance C. That is called as GARCH 01. Okay. Now, this is the series and it has already been created here. It has already been created here. Now, there is very important thing I would like to discuss. This is your conditional variance. This is your original price. I would like to plot these two. I would like to plot these two enough sulfur. Enough sulfur. I don't know. I would like to see something. So this was like to go access and labeling. Second to the right. Okay. Now be very careful. Students, be very careful. This is the graph of your conditional variance, GARCH 0, conditional variance. And this is your original series. Very good. Up to this point, most of the studies are finished up to this point. But see here, but see here. I'm going to draw what? Draw, I'm going to draw ellipse. If you see here, if you see, I don't know whether I'm drawing it correctly. If you see, whenever there is a negative shock, see the series is going down, series is going down. You will see the conditional variance going up. And whenever the series is going up, positive shocks, the volatility is smooth, is smooth. See here again. Okay, again, let's draw this thing here again. I would like to bring home one point. See here again. Once the series is going down, there are negative shocks. So the volatility is increasing. And come on, if you see at the end also, if you see at the end also here, if you see at the end also here, here also, once the original series is going down, once the shocks are negative shocks, the volatility is increasing. So this means what? This means what? Let us put it in simple English. Whenever there is a negative shock, there is more volatility. Whenever there is a positive shock, there is less volatility. This is called leverage effect. Leverage effect. Now, I would like you to draw this figure and put it in MS Word once we are writing the research papers. But there is one problem with the GARCH. There is one problem with the GARCH. With the GARCH series, there is one problem, and that is it never, it never, let me, I'm going to write the equation, the whole equation over and over again. Why? Because I would like to explain very many things to PhD students slowly and steadily. We need not to go fast because we are understanding the philosophy of time series. We don't need to solve the formulas or remember the formulas. We need to understand the philosophy. So specification same, okay. I don't need this thing. I need Arch. We'll go to Arch. Okay. And we have GARCH touch one model. Here we have legacy. We will have the legacy. Use legacy. We used as the optimization method. We always use optimization method in solving this thing. Okay. And we have the series. Now be with me. Now be with me. In this case, this is GARCH 1. GARCH, this is variance equation. This is mean equation. GARCH 1 1. This is ARCH and this is GARCH. It is called GARCH 1 1. So GARCH 1 1 is telling us what? It is telling us, in fact, that the positive and negative shocks they have the same effect. Whereas we have seen that it does not have the same effect. It does not have the same effect. It does not have the same effect. Where is that? Yes, does not have the same effect because the negative shocks have more effect, whereas the positive shocks does not have much effect. And this is displayed here. वो कमान है ना, वो कमान है ना. So we need to test what? We need to test another model which is called eGarch, which is called eGarch. And how to do it? How to do it? We will go for eGarch, eGarch, asymmetric one. And Dr. Marashi has taught you very well about eGarch. Okay, and now we have what? This thing, this C12 we have to study. What is this? Go to your notes, go to your notes here in eGarch, go to your notes and see what all is happening. What all is happening. We are interested in this gamma, in this gamma. Where is gamma? Gamma is C4, yani the fourth one, and it is negative and significant. What about here? It is negative and significant. So what does it mean? What does it mean? Consult Dr. Marashi and consult your notes. This is an exercise left for the student. Okay, there is one thing more. If we would like to study the leverage effect, we can also study T-Garch in a T-Garch. T-Garch. And in T-Garch also, we would like to have one here and we have the output. We have the output. This is for T-Garch. This is for T. And T-Garch has already been explained to you here. It has already been explained to you. Alpha plus gamma. Alpha plus gamma. Where is alpha? Alpha is C3, gamma is C4. Alpha is C3, gamma is C4. Alpha C1, C2, C3. You get my point? It is given over here, right? And it gives you like this. It gives you this. So you have to study this thing yourself and let us know what does it mean. What does it mean? You get my point? So we have T-Garch as well. This thing, minus 0.21 and so on and so forth. We need to study this thing. And here we have explained that alpha plus gamma is 0.17 versus alpha is 0.06 for positive shocks. Remember this thing. So alpha is C3 here. See, alpha is C3. It is only 0.07. But when it is added with this, it becomes stereophasic sabotage. This means what? This means what? This means what? Volatility responds more to bad news. Leverage effect. Leverage effect. And here I will tell you about something about from here. Something about from here. Okay. Leverage effect. This is going to tell you the leverage effect. The leverage effect is there. Yes, it is significant. This means what? This means what? This means this means that the bad news are affecting the prices more than the good news. So this is how you check the leverage effect. And then of course there is another one which is called what? Now I don't want this. We would like to have the variance. You remember this thing, Shiva? You remember this thing? Dr. Marashi taught you something here. These were just examples. Dr. Marashi taught something GARCH M. GARCH M. Where is GARCH M? This is GARCH. GARCH M. GARCH in mean. And in this mean equation, you also have the variance equation. And you have to see this lambda in the mean equations, whether it is significant. If this is significant, this means that volatility is going to affect your mean as well. Okay? Yani, this means what? Alpha 0.12, a 1% increase or 1 unit increase in conditional variance raises returns by 0.12%, reflecting a risk premium. You see here, this thing 0.12. It says alpha is C2. So this is alpha. So this is your lambda, and this is significant. In the mean equation, in the mean equation, in the mean equation, in the mean equation, we have to see this. Okay, let's see now. Options, Gauss mean. You see dialog in the mean equation. In the mean equation, though it is significant here, but it is not significant with my S&P 500. In this example, it is significant. But with me, S&P 100, the GARCH is now موجود في mean equation. This is your lambda. This is your lambda. يعني this thing. هذا. Apart from the mean, this mu means what? That AR 1, 2, 3, 4, MA 1, 2, 3, 4 plus the variance. So this gamma is going to tell you whether it is significant or not, and it is telling you here what? That the arch is not significant. This means what? This means what? What are we what are we what are we doing here? In GARCH M, it means what? That your variance or your risk is not related with your return. Your risk is not related with your return. And let me go to the notes of Rashi. This is GARCH 1.1. This is the other GARCH. And you have studied this. I will teach you this thing as well. Where is your yes? GARCH M includes the conditional volatility directly into the mean equation. This allows us to examine risk volatility influences returns. Is it influencing here? Is it influencing this lambda? This lambda impact of volatility on the mean. If ARCH M parameter is significant and positive, it implies higher volatility can leads to higher expected returns. If it is not, if it is insignificant, it may suggest weak or contrary risk return behavior. So here the GARCH is insignificant. This means that your volatility is not affecting the mean behavior of your stock, and this is a very good thing, because if it is affecting more, then of course your stock prices are very what you call weak, because the market volatility is going to disturb your stock prices. So this is a very important decision. Okay, with this I am going to conclude my video on ARCH and GARCH. The most important thing which I wanted you to study was what? Was this, that you have to draw the conditional variance and the original series together in order to study the behavior of the variance and the mean of the stock prices. You see, if it is going down, negative shocks has more effect than positive shocks. Remember this thing. So with this, I am going to close. You will be having this data yourself. Try studying this thing yourself. Try doing this thing yourself so that you can become experts in this thing. Thank you very much, students. So we have studied in this video ARCH, GARCH, and variants of GARCH. Thank you very much.